Okay, so on the last video, we ran the carpal simulation that came by default inside our external project when we created using the project wizard, right? So now I'm going to show you how to run any other simulation, even those that are not inside your external project, right? So um, we ran so I'm just going to go inside the project that we created. I'm calling this my IsaacLab project 7. This is our external project. If I go here on source, inside my IsaacLab project, tasks, you can pick any of these direct or manager based. They're just like different uh, code architectures that I'm going to explain in future videos. But what you see here is that they all have one task, which is the carpal task, right? So when you create the external project using the project wizard, they name this folder the same name as your project, my IsaacLab project or whatever name you use it. But I manually changed the name of this to carpal because it's the task that it runs, right? So um, all this to say that your project only has one task, the carpal task, right? And that's what we ran on the last video. But now what I'm going to do is I'm going to go into the IsaacLab master project that we cloned from the official NVIDIA GitHub repository. And if I go here on source IsaacLab tasks, I can see that it has many more tasks available, right? So all of these are tasks, right? Carpal and humanoid manipulation tasks. If you go on direct, there's even more here. Quadcopter, other humanoid, Franco robots, whatever, right? So um, the cool thing here is that from inside my own external project here, I can call these tasks that live inside the IsaacLab master folder and run them from my external project, right? So why would you want to do it, right? So um, these tasks that come with the IsaacLab project, they are like template tasks that are already available. NVIDIA made them available for us. And let's say that I want to train them tweaking their training parameters. I want to train them with different reinforcement learning algorithm parameters. I want to train them with different parameters for their reward functions, right? But I don't want to copy the entire tasks to my external project, right? Because this will be like duplicating heavy files in my computer, right? So what I can do is I can simply fetch the name, ID of these tasks and use the same command that we use to run the carpal task and passing their task ID, and it will run on the same way, right? And then later on the next videos, I'll show how to change the parameters, but now I'll just run any task here with their default parameters to show you how it works, right? So if I come here again, IsaacLab tasks, um, I want to pick this humanoid task here, right? So where do I find the name ID for this task? It's inside this init file, and here it is, right? So this function here, gym.register, is basically registering this task under this name in the gymnasium gymnasium registry, right? So the gymnasium registry is sort of like an address book for tasks that runs at runtime locally in your computer. And as long as you have registered the task by a specific ID, um, any project inside your Python environment that was installed, right? We installed this project before. Any project that is in the same environment and got installed can call the task from any folder, from any other project, as long as they've been registered with this function on this gymnasium registry, right? So here is what I'm going to do. So I'm going to use the exact same command that we use to run the carpool task here. So Python scripts, I'm using this RSL algorithm and running the train.py script. And I'll just pass the name of this task here, right? So what this is doing is saying, hey, script train.py, please run whatever commands you use to run any task and run this specific task here. So there it is. So it is opening IsaacSim and it will start running the humanoid task. Right, so again, it accessed the registry, it fetched the task by that name, and it's running the task here, right? So how does that happen, right? So as I mentioned, that Gymnasium is not only a phone book for tasks or a registry for tasks, right? It's also a standard that defines how you should code any task on Python, following a specific function structure or method structure, so that train.py, that same script, can call and run any task that was written using the same parameter, using the same standard, right? So let me try another one here. Let's go to direct quadcopter. Again, I'm gonna fetch here the name ID. So I just use the same command and I replace the name ID here. And then again, my external project is calling the IsaacLab master project, and it's running this quadcopter task, right? So again, the reason why this is possible is threefold, right? So first, when we created our external project and when we cloned the IsaacLab master project, we installed both in the same Python environment that we created in Anaconda prompt, right? This makes both projects importable on each other's code, right? And then secondly, they are all built. All these tasks are written using the same gymnasium standard, using the same functions, the same structure, right? So this allows the script train.py to run them with the same script, right? And then thirdly, they're all registered using gym.register by their name ID, right? So when I run this command, train.py runs, it will access the gymnasium registry, and because both projects are installed in the same environment and because their tasks are registered here, they can call each other tasks, and it's that simple, right? So just to illustrate a little better here, there's this little animation that shows how both projects communicate. So this is your external project. Um, and as you can see here, it's both projects are living locally in your machine, but my external project is a self-contained project, and it's separate from the IsaacLab master project, right? So when I run train.py, it will um, look up on the gymnasium registry, and it will tell IsaacLab which name, which task name it is looking for, right? And then the IsaacLab project will return the task that has that name and was registered on the gymnasium registry that is loaded at runtime here, right? So as long as they're all registered in using like gym.registered, they can be found under the same registry, right? So the name is looked up on Gymnasium, and then the task is the simulation is ran, right? And also there's a third component, which is the assets that run on this task, right? So you have the environments, you have the robots, right? And none of this is at first downloaded to your computer because, as you saw, there are like many different tasks, and each task has like many different assets that are very heavy. So what IsaacLab does is at runtime, it will call the NVIDIA cloud and then download only the assets of that task that is being ran, and it will cache that locally just for that run, right? And then that's it. And then it will run the simulation with these assets. And when the simulation is done, the logs and results will be saved only inside your external project, right? So your project is sort of like this controller that tells the IsaacLab master project which tasks to run, with which parameters, and logs the results, right? And the heavy stuff, the bulk of the processing is done by the IsaacLab master project on the other side, right? So this architecture keeps both projects pretty um, containerized and separated so that you can use your external project to do all the testing that you want without messing up with the master code in the IsaacLab, and also prevents you from duplicating or copying heavy files or code from one place to another, right? So that's it. Your external project is pretty much the controller that tells the IsaacLab master code what to do. And after the simulation runs, it just stores the results, and all the rest remains in the master project. And that's it. So on the next video, I'll show how to customize the parameters for other tasks that you want to call from the IsaacLab project, and how to store only the config files inside your external project and leave the main heavy master files in the IsaacLab folder.